In this video, I would like to talk about factoring by grouping. The key thing, which you can see here on the screen to understand about factoring by grouping, is that this is only meant to be used when you have 4 terms. If you have less or more than 4 terms, you do not want to be factoring by grouping. Okay? If we have 4 terms, like the example that you see here, 12x to the third minus 9x squared plus 4x minus 3. 4 terms. As the name factoring by grouping would imply, we are going to take this 4-term expression and split it up into groups, specifically groups of 2. So I'm going to group the first 2 terms and give them their own parentheses, and I'm going to group the second 2 terms together and give them their own parentheses. Now that I've done that, what I'm going to do is basically just GCF factoring, but with each group separately. Meaning right now I'm going to ignore the 4x minus 3, and I am only looking at the 12x to the third minus 9x squared. I'm just looking at this part. So I would ask myself then, what do 12x to the third and negative 9x squared have in common? What is a common factor that I could divide both of these by? 12 and negative 9 can both divide by 3. X to the third and x squared can both divide by x squared. So I will GCF factor a 3x squared out of my first group. Remember, inside the parentheses then we will write what's left over after doing the division. So 12x to the third divided by 3x squared would give us 4x. Negative 9x squared divided by 3x squared would give us 3. The x squareds would just cancel out. Negative 9 divided by 3 is negative 3. So now I want to look at the second group, my 4x minus 3 here. And I want to ask myself the same question. I want to say, okay, what common factor is there that 4x and negative 3 can both divide by? Now the answer here is not none. The answer here would be 1. Now there really isn't a whole lot that these ones have in common, but remember, every single term can always divide by 1. And so I don't want to just pull nothing out of this second group. So I will still pull out just a simple positive 1. It doesn't change anything inside the parentheses because 4x divided by 1 is still 4x, and negative 3 divided by 1 is still negative 3. But it does give me something that I've pulled out. Now here's the kind of weird part for factoring by grouping, so do make sure you pay attention to this. We want to look at this as 2 separate pieces, 2 separate terms. We've got 3x squared times 4x minus 3 as one piece, and we've got 1 times 4x minus 3 as our other piece. So if we think of this in terms of GCF factoring, what we'd want to ask is what is in common between these 2 pieces? Is there anything in common that we could pull out? Well, there is something in common. It's the entire quantity of 4x minus 3. 4x minus 3 is in common between both of these pieces. So I'm going to GCF factor the entire quantity of 4x minus 3 out of this problem. Well, if that's the GCF that we're factoring out, we know from past lessons we need that second parentheses where anything left over after the GCF happens is still there. Well, if we take 4x minus 3 out of the blue piece, the first piece, we'd be left with 3x squared. If we take 4x minus 3 out of the second piece, the pink piece, we'd be left with a positive 1. And this would be your answer to this problem, factoring by grouping. Let's take a look at another example here. Again, we should first check to make sure there's 4 terms exactly, or else factoring by grouping doesn't work for this. We also do want to check and make sure there isn't some GCF that we could pull out right from the beginning. You should always be looking for a GCF because that should always be your first step for factoring. In this case, we don't have a GCF. We do have 4 terms though, so this is a possible expression that could work for factoring by grouping. So again, we're going to group the first 2 terms and group the last 2 terms. In our first group, we have 35xy minus 5x. I want to look for a GCF. We want to look for something in common that both of those terms can divide by. Well, 35 and 5 can both divide by 5, and I also notice that both terms have an x in common. So it looks like 5x would be our GCF. 35 divided by 5 is 7, and then x divided by x cancels out, leaving us with just a y to go along with that 7. Negative 5x divided by 5x would simply be negative 1. The last thing I will say about factoring by grouping that you want to just probably write down as a side note, if the first term in either parentheses is negative, you want to factor that negative out. Again, if the first term in either of the parentheses is negative, you want to factor that negative out. Meaning, if we look at our second parentheses here, we notice that we have a negative 56y plus 8. Now 56y and 8 have an 8 in common, but if all I do is pull an 8 out, that's not going to make these parentheses match up. I need to pull a negative 8 out because, as we'll see here, negative 56y divided by negative 8, a negative divided by a negative is a positive, so we'd get positive 7y. And then 8 divided by negative 8 gives us a negative 1, and that's how we end up with parentheses that match in positive 7y minus 1. If you don't pull that negative out, it's not that you're GCF factoring wrong, because you're not, but for grouping, we need to factor that negative out to make sure that these parentheses match up. Because now that they match up, we can pull that 7y minus 1 out and have that other quantity where we have the 5x and the minus 8 that were left also together. So if the first term in either parentheses is negative, you want to factor that out. Otherwise, that's factoring by grouping.